Hello, welcome to this video on quantum computing roadmap. I am Shivani Rajput. I want to share aspects on quantum computing roadmap. No need to say that quantum computing is very fast and emerging technology that actually affects many industries and the societies at larger scale. What we really want to see is that it reached to a point where real world problems that could not be solved by classical computers are starting to get solved by quantum computers. It is doubtlessly seeing an exponential growth on its computer power, that is, quantum value. The quantum advantage is subject to be in picture in the next few years, where a real world problem will be solved efficiently using quantum computers that even the biggest supercomputer will not able to solve. And this is what the roadmap is designed for. So, as we look forward towards the quantum advantage, it's also important to appreciate what we have today. So, on the screen, it is the picture of quantum so this is what we have today. This is what is accessible through the cloud to thousands or the hundreds and thousands of developers. IBM published roadmap to show the whole world and the community how we get from what we have today. Before we look at the roadmap and think, let's talk about the quantum advantage. So it's important to understand few used cases where we use this. So we are going to so we are there are some challenges in discovering a new drug or medicine. So one of the key challenges is identifying an essential molecule that attaches to a particle target of interest and not to thousands of others, or which has really in side effect category. So simulating a complex molecule is not possible in classical computer, and it's actually possible in quantum computers, and all this interaction grows exponentially. So this is the first application in drug discovery and generally in chemistry. Now moving to the second, we have lost many of us to the deadly disease of cancer, or some had to go through huge treatment to treat cancer. The technology or the classification techniques that are used to identify and diagnose these cells that which are cancers or not are of less quality, and quantum computing can potentially improve the quality of the results in being able to identify complex structures like RNA, DNA, protein. So this is the second used case. The third one is also going to be very important for our country is in the area of fraud detection. So these are some particular use cases, and once we have the quantum advantage we should be able to solve. Now back to the roadmap. IBM published the quantum roadmap. The publishing of the roadmap, making it public, made in impression of two things. One is our need to the science behind it, that we continue to push for bigger or bigger improvement for the growth of the quantum system. The second is that our belief that we would be able to do the make the changes that is needed to get ready for quantum advantage in 2023 or beyond. So we see the roadmap starting from 2019 up to 2023. It shows the family of processor, namely Falcon, Hummingbird, Eagle, Osprey, and landing to Condor. Condor is the one that everyone has their eyes on. It has quantum volume of over thousands qubits. It seems like it's ready for solving some real world problems. Here I use the concept of quantum volume. Now I need to explain this. Okay, the quantum volume is basically a single number metric that measure the capability of quantum computers. It quantifies the large random circuit of equal width and depth that the computer successfully implements. So quantum computing system with high connectivity, large calibrated gate sets, and circuit rewriting tool chains are expected to have high quantum value. The important thing is here, these are the family of processor, right? Suppose Eagle is here, it represents family of processor that has quantum value of 127 qubits. So the advantage is that everyone know that what is coming, so they can design their roadmap. And it also important that there is huge advancement in the, in the volume from one family of processor to another, landing us to over 1000 qubits machine by 2023 and getting us ready for the real world application. Now, knowing that this is the published roadmap, our next job is to make sure that we are engaged in the community of developers and clients to make sure that we are engaging on right used cases, that we have access to real computers and simulators. This chart shows the roadmap also from software perspective. So the community and the people who can focus on building on the top of quantum system. Then comes the community of developers, that is the kernel developers, and they creates the runtime, and one of those runtime is the Qiskit runtime. Then there are dynamic circuits, there are circuit libraries, and going on to advanced control system. So that's the persona, or we can say set of community of developers who are going to actually contribute to build in the runtime itself. On the top of them, there is quantum algorithm, who are going to quantum algorithm developers who are going to take this runtime and create some pre-built quantum libraries and toolkits for certain domains that we have previously discussed, like natural science, finance, optimization, and all. And to make all this available by 2023 and estimated around 2023. And then on the top of that, there are community of model developers. They take particular use cases and build model using the quantum runtime. Um, Let me comprehend this. Above the quantum system, there is quantum kernel developers. They create high performance quantum circuit and they develop new interaction. Then the quantum algorithm developers, they rely on these circuits to develop groundbreaking quantum algorithms that might provide an advantage over present day classical solution. Then there is quantum model developers. They apply all these algorithms to real world use cases in automotive, finance, chemical, medical, optimization, etc. So all of that, if we look at 2023 axis, is happening around that time when we reach the quantum advantage. And once we have these use cases solved, the enterprise clients can start building an integration of the models into their work zone. So developers are going to be in the front and the center of quantum evolution. There are software development kits like Cascade, and that has so much. It depends that developers could start using and getting access to quantum computers on the cloud, real computers and simulators, and this is really a improvement, a big improvement. The way IBM offer access to the latest hardware system that scientists are developing through the cloud is really a big change, and urge all the developers to take advantage of this. We have access to open source Qiskit, have access to IBM quantum computing machine, so let's make use of it. Thank you.